See now, cell EMF and internal resistance. Suppose you have a battery. This is a positive terminal, this is a negative terminal. The battery is made up of what? Material, is it not? The material, the battery is material. Now, every material offers some resistance. That means battery resistance. The battery resistance denoted by small r. The small r is called internal resistance. What is an internal resistance? This is internal resistance of a battery or a cell. That means internal resistance means the opposition. What is internal resistance? Internal resistance. It is the opposition offered by the material, of this chemical substance or electrolyte, you can call electrolyte of the cell to the flow of current through it. See here, English is a very important. It is a opposition offered by material of electrolyte. What are the material? What is called electrolyte? See, in example, if you have a cell, see Daniel cell, Leclanche cells and all is there, whatever it is. See, here if you are keeping a copper, right? Copper. This you have studied in chemistry, right? Copper and here zinc. Remember the zinc. This is a metal zinc. Zinc in contact with zinc ion. What is zinc sulfate solution, right? Of 1 molar concentration, that is C1. And there is a salt bridge, right? Salt bridge is done by this one. And copper is in contact with copper ion. So copper sulfate. That means copper ion whose concentration is 1 molar in contact with copper metal. This is reduction potential, this is oxidation potential. All these things are done now, because what happens, the electron flows from here, current is flowing from this side to that side. So much electrons flows from this side, so zinc to electron, then current is flowing from copper to zinc, like this. So many chemical reaction takes place. This is not an electron flow in direction other. Therefore, the resistance due to the chemical reactions, these are electrolyte, all the things they put it in a single word. Therefore, you will get an internal resistance. Don't want all that. That what is EM of a cell is equal to E0 is equal to EM of the half cell. That means reduction potential minus oxidation potential. Something and all you get it. You will study that. Therefore, it is an internal resistance. Is that smaller. But in the examination, what they will ask you? What is an internal resistance? Internal resistance, this is only 1 mark. It is the opposition offered by the material of the electrolyte to the cell, to the flow of current through the cell. Okay, that you have to write it. Okay, now in CET or NEET, any examination, what are the things as asked? They'll ask you the factors on which the internal resistance depends on. What are the factors on which the internal resistance depends on? Tell me. One, temperature of the electrolyte. Temperature of what? Electrolyte. Then concentration of electrolyte. So 1 molar, 2 molar or so. Area of electrode. See, sometimes this what? The area of the electrode. Nature of the electrolyte. See example, hydrochloric acid release one ion. But sulfuric acid, if you take H2SO4, two hydrogen ion, right? Two electrons. Like this depends upon the nature. But this is very rarely they ask. For your exam point, for final exams, A level you study this only. Right? This is B level. Okay. Next, coming back to that, define potential difference of a cell. Potential difference of a cell. What do you mean by potential difference of a cell? Here, there are two types of things. This is the battery you have taken. Positive, negative. This is the battery. Now you are connecting, right, a resistor, or is a resistor, it may be iron box or a fan or any electronic appliance or a bulb, whatever it is, you are connecting it. Now current is flowing here from positive to negative, right? Previously what you will do now, this is a battery, you have a battery, positive and negative. Now I have a voltmeter. What is the voltmeter? Voltmeter is the measure which measures the voltage, okay, between this end, this terminal. Now I will connect it. It shows say 10 volt. It shows 10 volt. Now then after that, now I will connect the voltmeter. Now same voltmeter. It shows what? If I connect that same voltmeter, it shows 8 volt. What will happen? This is closed circuit. This is the open circuit. This is called open circuit. See, battery, positive, negative. Okay, positive. This is called open circuit. Open circuit. This is what? Closed circuit. Closed circuit. Understood? Now, here, what is actually going on? Here, this cell, it shows 8 volt. That means, according to theoretically, this battery, due to some chemical reaction, this take place, they push the electron. Electron is 1 coulomb of charge. See, suppose n number of electron form 1 coulomb, is it not? 6.25 into 10 to the power of something, you have calculated long back. So many electrons forms 1 coulomb. 1 coulomb of electron comes out with some energy. How much energy? 8 joules. This electron goes here. The electron flows like this direction. It will be coming like this. That means the battery push 1 coulomb of charge. 1 coulomb of charge with certain energy. What is that energy? 8 joules. This 8 joules here, 8 joules here comes here. Here. Suppose out of this, not 8 joules, 10 joules. Because it 10 volt, no. Therefore, here, from here to here, 10 joules. By the time it comes here 2 joules. That means 10 joules. How much it spend? This is called external resistance. That means it spend 10 joules of work. How much it spends? 8 joule of energy in overcoming the external resistance. Out of remaining 2 joules, from here to here, it spends 2 joules. That means 2 joules for internal resistance, 8 joule for external resistance. 8 joules for external resistance, 2 joules for internal resistance. Now when the electron flows in this direction, positive charge is said to be moving in the opposite direction. Therefore, we define electromotive force. What is EMF? That means terminal potential. This is also called terminal potential. This 8 volt also is called terminal potential. Therefore, first I will tell what is electromotive force. Electromotive force. What is electromotive force? EMF is also called electromotive force. How to define this? Define electromotive force of a cell. Force of a cell. It is defined as amount of work done. This is what? It is the amount of work done in transferring a unit positive charge. Unit positive charge. In bracket 1 coulomb of electron in opposite direction. Write it. Opposite direction. That is from negative to positive if you want. That means amount of work done in transferring what? 1 coulomb of positive charge around the circuit. Around the circuit. Right? Around the circuit. That's all. This is 1 mark. What is internal resistance? 1 mark. Internal resistance, 1 mark, you know. Now what is electromotive force? 1 mark. It is the amount of work done in transferring a unit positive charge or 1 coulomb of charge, right? 1 coulomb of charge around the circuit. Around the circuit. Over. Then what is the terminal potential? See here. Next I'll tell. This is the battery. Battery. EMF is what? 10 volt electromotive force. R is the internal resistance. Here what is happening? Here V dash, I'll write it. V dash is equal to 2 joules. Here V is called terminal potential energy. Terminal. This is for to external resistance. Current flows from what? Positive to negative, right? Current is flowing like this. Now what I do is here terminal potential. This is what is called potential difference of a cell. This is the potential difference between the two electrodes. I said no. Potential difference between the two electrodes when it is a closed circuit. In a closed circuit. This is 1 mark. This is called terminal potential, 1 mark. Therefore, they'll ask you what is define the term potential difference of a cell. It is defined as what? It is defined as the potential difference of the two electrodes of a cell in a closed circuit. In a closed circuit. That is the definition. What are the relations? See the derive, they may ask you, right? This is 1 mark. Terminal potential. Okay. Now they may ask you derive the expression for the current through external resistance. They'll ask you for 3 marks or 2 marks. 2 mark or 3 mark, it depends. See, consider an external circuit. See, this one, write on the same diagram. Consider an external resistor. Consider an external resistor connected to a cell. Connected to a cell of what? EMF E and internal resistance smaller. Right? By definition, what is that? Of electromotive force. What do you write? You write this by definition. And electro EMF is what? I'll write it. EMF of a cell is what? What is that? What you have to write? Same thing, is it not? The total work done, same thing, total work done in transferring 1 coulomb of charge. 1 coulomb of charge are positive charge, unit positive charge around the circuit, out of which a part of energy. Work is nothing but what? Energy. Now energy is utilized to overcome an external overcome an external resistance R, that is in bracket, right, that is equal to Vt, is known as terminal potential energy, terminal potential difference. Okay, and the remaining part, which is the remaining part? Internal energy, no? What is this? Yeah. Right? Definition of potential difference of cell. Then the remaining part to overcome the internal energy. That's what 2 cells. 8 joules, then 2 joules. Right? The remaining part is to overcome the internal resistance of the cell, right? That is bracket V dash, according to what? Next, according to law of conservation of energy, E is equal to V plus V dash. Right? 10 joule is equal to 8 joules plus 2 joules. Law of conservation of energy. From Ohm's law, E is equal to V is equal to IR, correct? This is I into small r. Then current is common factor, R plus R is equal to EMF. Therefore, current is equal to R plus R. Therefore, current through the, what do you write? Current through an external resistor is equal to, what is that? EMF, sometime effective EMF, you write effective EMF, electromotive force to total resistance. What is total? Is external plus internal resistance. You understood? Now what you have to do, how they will allot the mark for this? For 3 mark question, first write the diagram. Don't Vt you write it, R you write, V dash you write, current you write, positive negative write. Don't write this value, E. Then define the term. Okay. If you want, here you need not mention this already. Here you consider a cell, all these things you describe. You writing this EMF and all these things you are describing, is it not? Where is this? You are describing up to this. Description fully 1 mark. Cell, this EMF, internal resistance, description 1 mark. Then what? Here you are writing now this part. What is that? E is equal to total work done is equal to the energies. That means V plus V dash. This you are mentioning this. This up to this 1 mark. Then remaining part is 1 mark. 3 mark they'll ask you. You understood? Now, these are simple derivations. We have covered how many? Cell, right? Then again, what is potential difference of a cell? What is the terminal potential? Terminal potential difference of a cell we are done. Then derive an expression for that we are done. Okay. Therefore, all these things if you study, then I can continue with the. So it is not proper. Okay. Then I can continue. What is the simple sum I will give you? Very simple sum. These are all they'll ask you for 1 or 2 marks. The thing. Here look. A cell. This is a cell. Right? Of 2 volt and internal resistance 1 ohm. I can form my own problem. Okay? A cell 2 volt internal resistance connected to a external resistor. Connected to a external resistance 9 volt or 9 ohm. Find the potential difference in the cell. Find the potentials. See, potential difference of a cell means what? It is called terminal potential energy. It's called terminal potential, current into resistance. This is external resistance. This is the current. Okay. What is the current? Current is equal to EMF by total resistance. Correct? What is the current? Current is equal to EMF is how much? 2. External resistance 9. Internal resistance 1. Therefore, how much? 2 by 10. Right? Or 0.2 ampere. Current you have got it. What is terminal potential? Terminal potential is equal to V is equal to IR. No? V is equal to I into R. What is the current? 0.2. Resistance is 9. 1.8 volt. Vt is equal to 1.8 volt. What is potential difference across the cell? Potential difference. Here what is the question? Potential difference across the cell is given. What is the V dash? V dash, what is the name here? Potential drop inside the cell. That means 0.2 volt. Understood? This one. Therefore, we can find out what is a battery. When I ask what is called a battery. What is a battery? When I say battery is what? Combination of cells is called a battery. Now, battery, there are different types of battery, cell, Leclanche, Daniel and all you come across. But 1, 2, 3, this is page number 4. Okay, fine. Now, in the battery, what I do is, suppose I have a EMF. E1 is equal to 5 volt. Right? This is E2 is equal to 2 volt. What is the EMF here? EMF is effective EMF is equal to 5 plus 2, 7 volt. In the series. Here what is the internal resistance? R1. This is R2. That means internal resistance R1 and R2. Therefore, effective internal resistance. What is effective internal resistance? R1 plus R2. Can you follow? Understood or not? Better. On the other hand, what I do is I have a battery, right? Here negative, here positive. Negative negative connected, positive positive connected. This is what? 5 volt, this is 2 volt. This is E1, this is E2. Then this is R1 and R2. What type of connections? Negative connectors. See, actually this is the thing, right? You are connecting like this. This is the meaning. If a connection means what? Two negative connected to a common point, right? Two positive connected to another positive point. Positive connected to a positive point. This is negative. Understood the meaning? A negative to a common point. Okay, A. Positive connected to point B. This is E1 and E2. Therefore, what is effective EMF? Effective EMF is equal to E1 difference E2. Difference means what? Whichever the big. What is the big here? 5 minus 2. Therefore, 3 volt. Then what will happen to this one? Then again, what is the resistance? This is R1 and R2. Here two internal resistors R1 and R2 in parallel. Though it looks like series, it is a parallel only. Then what is the effective resistance here? 1 by reciprocal of parallel is equal to 1 by R1 plus 1 by R2, right? Then what, LCM R1, R2 plus R1 is equal to 1 by R parallel, or R parallel is equal to what? R1, R2 by R1 plus R2. This much time you need not waste also. Directly can tell now, if R1 is parallel to R2, then what? Product divided by sum, no? This is called R parallel. That only this. Now, when two cells are connected in parallel, what you write? Effective internal resistance, this effective. Therefore, while doing the problems or for doing any type of derivations, it is definitely helpful for you. Right? Okay? Therefore, another thing is what? When I have, this is the battery. Like this EMF, R is the internal resistance. There are 3 cells, 1, 2, 3, 4 cells are there. 4 cells or N cells are there. What is effective EMF? Effective EMF is N times E plus E plus plus. What is effective internal resistance? Effective internal resistance is equal to NE. Suppose same thing I connected in parallel. All are equal or connected in parallel. All are E only. What is effective EMF? E only, not NE. NE. Okay. What about the internal resistance? R. 1 by R internal resistance equal to 1 by R plus 1 by R plus 1 by R. 1 by R is effective is equal to 4 times 1 by R. Or R effective is equal to what? Reverse it. R by 4. In general, R, there are N cells are connected. R effective is equal to R by N. These are things you're supposed to know. This will be helpful for next derivation and problems. For CET also. Alright? I'll continue when the cells are series, not resistance are series. Now we are going to do cells are series, cells are parallel. Definitely they will ask you for 5 mark question. You be prepared for that. Okay? Thank you.